Hello, everyone. Today, we are going to talk about understanding and debugging DNS request flows in a Kubernetes cluster. Before we start, my name is Qasim. I'm from Pakistan, currently living in Hamburg. I work as a software engineer at Microsoft. I'm one of the maintainers for the project called Inspektor Gadget. We're going to talk about this project in this presentation. Apart from that, I also own and maintain CoreDNS header plugin. And other than that, I also like to contribute to other cloud-native projects. In terms of the agenda for today's presentation, we'll start by understanding DNS components and request flows. We'll then deep dive into different tools that include CoreDNS log plugin, Hubble, Inspektor Gadget, and then we'll use all the knowledge we have gained to actually debug a couple of scenarios. Hopefully, at the end of this presentation, you'll have an idea how to debug DNS issues in a DNS cluster, in a Kubernetes cluster, sorry. So in order to debug DNS issues, we first need to understand different components via which the request flows. So these include application pod, node local DNS, kubeDNS service, CoreDNS pod, and upstream DNS server. In terms of the request flow, the application pod makes the initial request. And depending on if you have a caching agent like node local DNS, or you don't have it, the request will be forwarded to the CoreDNS pod or the caching agent. Add the caching agent, like node local DNS. If it's a cache miss, the request is forwarded to CoreDNS pod. Similarly, at CoreDNS pod, if the domain we're trying to resolve is an external domain, it'll be forwarded to an upstream DNS server, otherwise answered directly. So this slide already highlights the different challenges with DNS in Kubernetes cluster. There are too many hidden systems. If we make a DNS request and it fails, we really don't have any idea at which component it failed. It's not really easy to trace the DNS request flows across the entire cluster. Tools like TCP-dump, they offer a great way to deep dive into request flows, but they lack cluster-wide aggregation and Kubernetes enrichment. So now that we have a slight idea how DNS request flows can help us, let's try to deep dive into them using different tools I like. Just a disclaimer, whenever in this presentation I talk about tracing a DNS request, it'll be for example.com from a pod named mypod running in a demo namespace on a Minikube cluster. So the first tool I want to talk about is CoreDNS log plugin. It's one of the core plugins in CoreDNS, which means you don't need to install anything. It just needs a keyword log in the core file. This core file is normally located in the kube system namespace. So you can just edit it, put that log keyword there, and it should start to dump all the requests in the standard out. In terms of the format for this specific plugin, we can filter by the names we're interested in, for example, example.com, and we can also filter based on the different response classes, like success, and etc. In terms of the output, this is a sample output from one of the requests being processed by a CoreDNS pod. So you can see here we have the client IP, which is actually my pod IP. You have the query ID, you have the response code, and you have the response duration. And you have all other information as well. On the bottom of the slide, I have the default logging format, but you're free to choose any other format which is helpful for you. The next tool I want to talk about is Hubble. Hubble provides network, service, and security observability for Kubernetes. It's built on top of Cilium and eBPF. You install it as a Kubernetes daemon set. It has multiple interfaces, for example, matrices, service map UI, and flow inspection. In this particular presentation, we're going to focus on flow inspection using Hubble CLI and JQ. Before we start to trace the request flows using Hubble, we need to do some setup. And for that, we need to make sure we install Cilium with L7 proxy support. Then we'll need to create a couple of Cilium network policies to enable the DNS traffic visibility, one for my pod and one for CoreDNS. Let's try to see these policies. So the first one, we see that I have a label which makes sure that this policy only applies to my pod. One thing to keep in mind is that these network policies will also block all the traffic. So it's not just for visibility. This is more, you can do more with it. So for this purpose of this presentation, I opened all the traffic to all the entities. Next, we need to have a rule that makes sure that the DNS traffic will actually pass through the NY proxy. So all the flows will be enriched by L7 information. Just like a policy for my pod, we have a policy for CoreDNS, and it just uses a different label, and it's in the different namespace. So assuming we have installed those policies, we have Cilium with L7 proxy support, we then go ahead and try to trace the flows. So in this case, I have a sample output from Hubble. You can see already at the top, maybe I can point there. Yeah, there. So we can run the Hubble observe command. We can pass the protocol we're interested in. And then we start to see the trace. In the first line, you can see I have a request from a pod going towards a CoreDNS pod. And you can already see we have all the query information already in there. Now, the name we're trying to resolve is actually an external name, which means the request will be forwarded to an upstream DNS server. So as soon as it reaches the CoreDNS pod, here the CoreDNS pod needs to send it to an upstream DNS server. In our case, this is the upstream DNS server. So you can already see that the request ID for this one is different from this one. That means it's a different request or a new request that CoreDNS then needs to make. Finally, we get a response back from the upstream DNS server back to the CoreDNS pod, and then eventually it gets forwarded back to the my pod. This already gives you a great overview of how you can observe the requests across different components. One other thing I really like about Hubble is being able to run the commands again with a specific time period. So for example, I can say only observe for last 5 minutes, use the JSON output, and use jQuery to, for example, filter for, like in this case, I'm filtering for if there are any errors in the R code. And you can see if those two pods had issues resolving DNS in the last 5 minutes. So the next tool I want to talk about is Inspektor Gadget. It is a set of tools that empower users to inspect Kubernetes and Linux systems. It is also an observability framework that allows you to build and share custom gadgets. It can be used in Kubernetes. As the daemon said, and interacted via kubectl gadget crew plugin, or you can try it out without installation using kubectl no debug. Before talking about how to debug your cluster using it, I want to give an idea about what a gadget is. So a gadget is an OCI artifact. On the left side, we have an IGCLI, which allows you to build and publish gadget images to an OCI registry. On the right side, we have an OCI registry in which there is a gadget living. The gadget is composed of eBPF programs, WASM modules, and some other components. You will run these gadgets just like you run a container or install a Helm chart from an OCI registry. As a user for these gadgets, you don't need to care about building and pushing them to OCI registry, because Inspektor Gadget already has a set of official gadgets we publish. And you can find them in our official documentation, or you can head to Artifact Hub. We have our own kind there. And you can filter by these official and CNCF and verified publishers and see a list of gadgets that might be interesting for you. For the purpose of this presentation, I'll talk about Inspektor Gadget DNS Gadget. As the name indicates, it traces request and response using eBPF. It then post-processes that information using WASM. Like I already mentioned, these gadgets are actually OCI artifacts, which means that you can modify the code, you can build them, push them, run them across your entire cluster in a modified and a custom way, anything you like. I have the link for the either QR code for the guide and source code, just in case you're interested. OK, so now let's try to actually debug an application pod using Inspektor Gadget. So in this case, we have kubectl gadget run. I have a text highlighted here. This is actually the OCI image we were talking about. This, by default, resolves to the Inspektor Gadget official GitHub container registry. Just like for Docker, it resolves to Docker Hub. And then we have some filters here for a specific namespace and a pod. In terms of the output, you see we have a couple of events here. One is a query, one is a response. And in terms of the enrichment, we have all the Kubernetes enrichment. We have the mypod IP here in the source. We have the kubeDNS service IP in the destination. And we also have the query information and the response code. So this is like a very compact way. If you just want to see the DNS request for a specific pod, you can do it like this. Let's try to expand the scope a bit. Now, in this case, we just don't want to see what happens to our request at an application pod. We want to see what happens at, for example, in CoreDNS. So in this case, what we're seeing, we're adding, we want to trace the events in kube system namespace. We are filtering for specific pod names and also for a specific name. And then here you can see we can also have different fields depending on what we like. Here you again see, just like for Hubble, we have two different DNS requests, one with this ID and one with this ID. And the first two lines are actually the request leaving the my pod and arriving at CoreDNS pod here. The next two lines, again, is the new request generated by CoreDNS pod towards the upstream DNS server, and then the response back. And then eventually, the last two lines is this response actually getting back to the my pod. Let's try to expand the scope even further. In this case, if we won't filter for specific pod names, we should be able to see more context. Let's try to see what do we have here. All these lines without enrichment are actually what happens to the request actually at the node level. You can confirm this with the network namespace ID, which is actually for the host. The first highlighted text is actually the initial client request being forwarded via the host. So here, IP table is doing some magic, converting the kubeDNS service IP to a specific CoreDNS pod. The request then reaches the CoreDNS pod here. Then the CoreDNS pod needs to make a new request here. Again, the request needs to come out of the CoreDNS pod, being forwarded on actually the host, sent back to the upstream DNS server. Eventually, we get the response back. That's again need to be forwarded via the host back to the CoreDNS pod. And at the CoreDNS pod, again, it needs to then send it back to the original my pod, which actually initially made the request. You can see that this is actually the same ID as this one. So the last highlighted text is actually the initial client DNS response being forwarded via the host. At this point, you can already see all these different tools. They have different scope. They can help you to trace request flows at different stages. If you're only interested in debugging an application pod, you can do that. If you want to go a bit deep and actually understand what happens with the request at the node level, you can also do that. So it really depends on the use case or what you're trying to debug. So in order to summarize, we saw different tools and how they help us into deep dive into request flows. You can use them separately, or you can use them together. In terms of CoreDNS log plugin, it's ideal for initial inspection. However, the scope is only limited to CoreDNS pod. It requires configuration changes. Like I showed, you need to change the core file. Or if you're only interested in certain domains, you need to put filters in your core file. In case of Hubble, it provides a compact overview for request flows. And it allows you to do retrospective analysis. But for Hubble, you need to have Cilium CNI, and you need to configure certain policies to have L7 visibility. In case of Inspektor Gadget, it offers rich DNS traces with OS context and Kubernetes enrichment/filtering. It is extensible through custom Gadget images, but it doesn't yet have support of TCP, DNS over TCP. So for example, if you have this node local setup, we might need to do something there. So now we have talked about different request flows, and we have gained some knowledge around that. Let's try to run some debugging scenario and see if that helps the knowledge we have gained in debugging these scenarios. So the first scenario I'll talk about is verifying health of an upstream DNS server. So in this case, what we want to do is that in our CoreDNS pod, we have an upstream DNS server. We are making some requests to this upstream DNS server, and we want to see if the requests that are leaving the CoreDNS pod and going to the upstream DNS server are actually doing OK. Let's start the demo. I hope everyone can see it. So the first thing we want to do before tracing the request is to make sure that there is a pod making those DNS requests. And also, we want to make sure that we don't have any cache plugin there, because if you enable caching in the CoreDNS, it will cache the request going to upstream DNS server, so you won't get a trace for that. So the first step is just getting rid of the cache plugin. And we do that by just removing the keyword cache from our core file. Once we have done that, we need to restart the CoreDNS pods. That's just to fast roll out the configuration. Once done, I'll just quickly peek into the test pod I was talking about. In this case, we have a DNS request container. It's actually making a request to example.com and also to unknownexample.com, which means we'll have requests with and without errors. So once we apply this pod, at this point, we'll already have upstream DNS request because we don't have any cache plugin, and we also have some pod in the demo namespace generating those requests. The next step I want to do is now run this DNS gadget I was talking about and see what it shows us. Let's try to run it a bit. OK, great. I think that's enough. In terms of the different flags, we only care about the kube system namespace because we only care about what CoreDNS is forwarding to an upstream DNS server. We have the label, which actually selects the CoreDNS pods. We only care about the responses. We don't care if the queries are getting there. We have the source address, which in this case is an upstream DNS server. So you can figure that out by looking at your core file, or you can check out your hostresolve.conf. And then eventually, we have some fields we are interested in. In this case, we can see there is a response coming back from the upstream DNS server towards the CoreDNS pod, and it contains the return code. In this case, it's success, which we expected, that example.com would be successful. And for unknown.example.com, we see a name error because it doesn't exist. So running such queries will allow you to actually see if a specific name server is doing fine or not. Let's go back to the presentation. The next scenario I want to talk about is actually how to identify if a specific DNS request is failing at a specific component. In order to do that, let's again start the demo. OK, so in order to showcase that, we need to break something. And in order to actually break CoreDNS, I'm also going to use one of the CoreDNS core plugin called Erratic. We are interested in dropping all the requests for example.com. So in this case, we need to have a block just for example.com. And in this block, I'll actually add the Erratic plugin block. And in this block, I'll say drop everything. So once that's done, that means whenever a request from example.com from an application pod, which is CoreDNS pod, it'll be dropped. So let's just save this configuration and wait for it to roll out. Again, at this point, we have done the basic setup, and let's try to trace the request and see what happens. Again, let's try to see different flags here. So we have, again, we only care about what happens to the request in demo and the kube system namespace. We have a filter for example.com. That's important in the end. And then you have different fields in which we are interested. Now we need to go to a different terminal and actually generate a DNS request. So in this case, we'll need to start a pod, again, in the demo namespace called mypod. And we'll use NS lookup to actually generate the DNS request. I'll just look up for A records, and I'll only retry once so that the trace looks cleaner. And then I put the domain name, and we try. At this point, you already see that the NS lookup is stuck. That means that something is wrong with our cluster. And that's already a sign we need to do something. So it times out. That means we had an issue with the cluster. And let's try to go back and see if the trace can help us. So here is the trace we got. So the first line here is actually the request leaving the application pod. That means the NS lookup was all good. It was able to send the request. The second two lines are actually something happening on the host because they don't have enrichment. And here you can see that IP tables is doing some magic. This is the IP for the kubeDNS service. It gets translated to one of the CoreDNS pod IP. So that went fine, so nothing wrong on the host as well. Eventually, the request reaches CoreDNS pod, but after that, we don't have any trace. So at this point, we already have an idea that this request went wrong at the CoreDNS pod. Let's get back to the slides. OK, great. So to conclude, the first step for debugging DNS is actually understanding the different components and request flows. And for that, we have CoreDNS log plugin. We have Hubble and Inspektor Gadget. This presentation was just a starting point, because the trace, they can change depending on your CNI and DNS setups. Like in this particular case, I didn't talk about how to trace across node local DNS. But if you have more components, a complex architecture, you should be able to do that. But the feedback is highly appreciated. All the three tools I talk about, they have really active communities. So please feel free to reach them out and ask them any questions or tell them any suggestions you have. And finally, I have the slides and the different policies and scripts I used for this presentation at this QR code. And thank you so much.
Thank you for this very interesting session. We were a little bit ahead of time, which is cool, because if any of you has some question left, then please use this Slido app and ask for the questions. So we, for now, have two. The first one is, how can you correlate events across different tools?
OK, perfect. I think that's a great question. So one of the things when I was trying to show the output for different tools, they all has this ID in the request. So for that means this ID is actually set by the client. In our case, it was NSLOOKUP. And all the three tools, Hubble, CoreDNS log plugin, and Inspektor Gadget, they have the IDs in their traces. So you can actually use them to correlate all your requests across different tools.
Got it. Perfectly clear. Next questions, and we have more coming up. Regarding debugging DNS, what are your feelings towards system D resolved?
Okay, so I think one of the things when I was talking about, like for example, particularly Inspektor Gadget, is that it allows you to trace something that's happening on the host. So it's not just giving you what's happening in the containers, but actually on the host as well. So you should be able to see different, like for example, traces related to system D. But if that doesn't work for you, we also have a tool called IG, which is for Linux host. So you can use that to debug containers and also processes on the nodes. So that should help you to deep dive into system D resolver.
I told you we have more questions coming up. Does Inspektor Gadget work with any CLI plugin?
Yes, that's a great question. Yes, we have our own daemon set installed, and we use eBPF to trace events. And since it's a framework, so you can write your own gadgets, and it has no connection with the CNIs.
OK. The next one is very interesting. Inspektor Gadget or Tetragon? When to use what? I like this one.
I think this question is more about, like, for example, I haven't tried a lot the Tetragon. I think it's focused on security. Inspektor Gadget is more trying to be a framework which allows you to do custom stuff. Right now, we're focused on inspecting. Maybe in future, we allow you to also see you can definitely right now trace if there are any malicious files and all that stuff. But right now, you cannot really do anything to block them. So that's probably something in the future. But right now, if you want to enforce security, probably Tetragon is the choice for you.
OK, next one. Does a service mesh like Istio interfere with how these debug tools work?
Yeah.
Tough questions, I know, yeah.
Yeah. Again, I think in terms of, I don't see an overlap with Istio. I think it's for example, there is no requirement from us from the CNI. So you can give it a try, but if you have any feedback, any issues, you can reach out to the community, and we can see what we can do there.
OK. How would you debug trace the CoreDNS node cache?
That's a good question as well. I think I skipped that in my presentation. It's because then it's too many components. But I think that's something probably I'll try to put in the documentation. But one interesting thing about node local DNS is that it's DNS over TCP. And especially in Inspektor Gadget, we can only do right now UDP. But since it also runs in a kube system namespace as a container, as a pod, so you should be able to trace the flows. I haven't tried with Cilium, Hubble, but it should be there already. But for Inspektor Gadget, we're getting the support for TCP so that you can also trace that.
All right, and the last question. Which of the three tools would you use if you see sporadic DNS resolve timeouts in production?
OK. I think that's also a great question. I think in terms of, like I talked about CoreDNS log plugin, I'm not sure if you're able to enable the visibility for all your requests. If you only have an issue with a specific domain, you might do that, but it only gives you context for CoreDNS pod. But if you're sure that's where your issue relies, then you can use that plugin. But if it's more about the other, in general, issues, and you want to understand which component, then again, if you have already Cilium there, then you can give it Hubble a try. But if you don't have anything, you have any other CNI, then you can definitely try Inspektor Gadget. And in Inspektor Gadget, like I told you, already have this kubectl debug node functionality, so you don't really need to install anything. You can just run it against a specific node and get a trace for it, and then debug it as you like.
All right, one last for the show. Is Inspektor Gadget available in GA? We had a lot of great questions. Nice.
Yeah, I think that's another great question. So if by GA you mean 1.0, so we're getting there. But all the feature I right now talked about, nothing is in experimental. You can deploy it, you can test it, and we'll take the feedback, and then we'll fix them. But right now, you should be able to test everything. There are no known issues to us right now.
All right, and that closes our question sessions. Thank you very much for this very interesting session. Thank you all for those very interesting questions as well. A big round of applause for you.
Thank you so much.